So now the charge distribution on the surface of conductor, if you just inject or if you take out some charge from that sphere, the remaining charge will redistribute so that its potential will be same and the electric field inside the conductor becomes 0. So I'm just taking out this two sphere of radius r1 and r2 from this whole sphere and then just connecting it with the help of some wire. So we know that the potential at P is same as that of your potential at Q. So because of this potential at point P, let assume that which is your Q1 upon 4 pi epsilon naught R1 is same as that of your Q2 upon 4 pi epsilon naught R2. Then you can write it down the surface charge density. So that is a sigma, that is a total charge, again that is a total area. So let it is nothing but 4 pi r square. So instead of this Q1 you can write down that is a sigma into 4 pi r1 square. Then again for this 4 pi that is a epsilon naught r1. Similarly sigma into 4 pi r2 square upon 4 pi epsilon naught r2. So this one of the r will get cancelled and you will get that sigma r1 is same as that of your sigma r2. So in short you can write it down that is a sigma into r, that is a surface charge density into the radius of that sphere. The product is going to remain always constant. So that is also called as a uniqueness theorem. Now how the charge particle is going to behave in some external electric field. So let at the charge I am going to place one charge minus q at the center and another charge, for example plus q2 at the point B, and this charge q2 is going to wield in this circular manner in this external electric field. So what are the different forces which are going to act on that charge q2? So first of all I will write it down the force F1, which is nothing but your Coulomb's force of attraction. So you can write down this is nothing but the Coulomb's force of attraction. Then this charge q2 will experience some, again you can say that the repulsive force, which is nothing but your because of your external field. So that force also you can write it down, that is nothing but your F, that is we simple write down E is equals to F upon Q. So F is equals to your Q2 into E. Again we know that to perform that necessary circular motion there is a centripetal force. Then you can write it down that is a tension in the string. So if I want to find at this highest point H, so obviously at highest point H the resulting force is nothing but the centripetal force. Assume that this is the circle of radius r. Then you can write down this F1 is acting towards the center, F2 is acting away from the center. Again you can say that this tension is always acting in the downward direction. Again that weight of that charge is also acting in the downward direction. So this is how we can just write down this condition so that it will perform that necessary your circular motion. So that is your motion of a charged particle in an electric field, where we have just considered the various forces acting on that charged particle.